Woohoo! Welcome back. Today we're going to be multiplying matrices. Yay! With our friend and yours, Neo. And we're going to be using the techniques that I went over in the last video to multiply two matrices. And hopefully you remember that in order to multiply two matrices, basically we need them to be the proper size. Unlike everything else in math, they don't have to be matching sizes. In fact, what needs to happen is when we look at the dimension, the two numbers that are closest to each other have to match. What does that mean? Well, this matrix, 1, 2, 3, 4, 5, 6, needs to have a dimension that will fit this matrix, 5, 6, 7, 8. So let's take a look. 1, 2, 3, 4, 5, 6 has 3 rows and 2 columns. So it's a 3 by 2 matrix. This matrix has 2 rows and 2 columns. So it's a 2 by 2 matrix. And if we want to be able to multiply them, these two numbers have to match. They do. So we're going to be able to multiply them. In addition, the resulting matrix, whatever the matrix we get, is going to have a size or a dimension of 3 by 2. So once the middle two numbers match, we can cover them up. And then whatever's left on the outside, that's going to be the dimension of the resulting matrix. Woohoo! Okay, so let's go ahead and get started on multiplying. So if I'm going to multiply 1, 2, 3, 4, 5, 6 by 5, 6, 7, 8, I'm going to end up multiplying row by row and column by column. So first I'm going to do, well, here, let me write this out here. This one's going to be row 1 times column 1. So row 1 times column 1. This is going to be row 1 times column 2. Row 1 times column 2. This is going to be row 2 times column 1. And row 2 times column 2. And then in the last spots, row 3 times column 1. And row 3 times column 2. And hopefully you're going to notice that, wait a minute, these are actually the identities of each of the entries. So the entries here, like this entry, which is row 1, column 1, that's its position, is actually, the way you get to it is by using row 1 of the first matrix times column 1 of the second matrix. So hopefully all of these things work together to help you remember what goes where. And I'm going to remind you that the technique I'm using is not the only technique. There are other techniques for multiplying. So definitely talk to me, talk to tutors, look on the internet. You may find someone doing it in a way that I've never even seen that you're like, oh my gosh, this is it. So look around for different techniques. I'm going to use the traditional technique where here I'm going to do row 1 times column 1. So I'm going to match up 1, 2, and 5, 7. So it's going to be 1 times 5 plus 2 times 7. And then over here, I'm going to do row 1 times column 2. So that's going to be the first 2 multiplied, 1 times 6, plus the second 2 multiplied, 2 times 8. And as we go through this, you're going to notice everybody doesn't get to multiply times everybody. Like the 1 only matches up with the 5. It doesn't also multiply times the 7, right? We don't have a full distributive property. It's first with first, second with second, etc. Okay, let's go down to the middle row. This row, we're going to row across and fall down. So 3, 4 times 5, 7. That's 3 times 5 plus 4 times 7. First times first plus second times second. 3, 4 times 6, 8. That is what? What's that going to be? You got it. 3 times 6 plus 4 times 8. And you're going to notice, look, it's always going to be times 5. And the second one's always going to be times 7. This one's always going to be times 6 and always going to be times 8 because we're multiplying in each column. We're multiplying times these columns. So you're going to see a lot of patterns. Hopefully they will all work together to help you get better and remember this technique because it really is one you have to practice. Well, I will say it's one I had to practice. Okay, we're going to go across and down. So this one's going to be 5 times 5 plus 6 times 7. And here it's going to be across and down. 5 times 6 plus 6 times 8. Notice that in the patterns I get 1, 3, 5, 1, 3, 5, 2, 4, 6, 2, 4, 6, 1, 3, 5, 2, 4, 6. Then we've got 5, 7, 5, 7, 5, 7, 5, 7, 6, 8, 6, 8, 6, 8, 6, 8. So you should see these patterns. Okay, next up, I actually have to multiply them. This then just becomes the matter of multiplying and adding. So I've got 5 plus 14. I've got 6 plus 16. I've got 15 plus 28. I've got 18 plus 32. I've got 25 plus 42. And I've got 5 times 6 is 30 plus 48. So altogether, I have 19. Let's see, this is going to be 43, 67, 22, 50, and 78. Now, I did something interesting. I chose to do something interesting with this one. If you look back at the previous problem that we did, we multiplied 1, 2, 3, 4 times 5, 6, 7, 8. Let me write that down because it'll be easier. So the previous problem was 1, 2, 3, 4, and we multiplied that times 5, 6, 7, 8. And when we got that one, we got 19, 22, 43, 50. Right, that was a 2 by 2 times a 2 by 2, and we got another 2 by 2. So how is that related to this one? Well, notice that this matrix reappears here. We just have an additional row. So let's look at what happened. I had 1, 2, 3, 4 in the previous problem. This time I have 1, 2, 3, 4, 5, 6. So I added an additional row. And what does that do to my product? It just adds an additional row to the product. So there are tons of patterns to notice with matrices. And these patterns are all going to be really awesome and wonderful and helpful in linear algebra. So definitely take a minute to smell the numbers or something like that. You know, revel in all the patterns and noticing all the coincidences and tuck those away for later use. Okay, let's do another one. Woohoo! We love matrix multiplication. Okay, next up, let's multiply these two. Okay, what is the first thing we do? First thing we do is check the dimension. 1, 2, 3. 3 rows times 2 columns. And this one's 3 rows times 2 columns. And then we say 3 by 2 times 3 by 2. And we say, oh no. Oh, sadness. I can hear the gnashing of teeth from here. These can't be multiplied. I know, I hear you all being like, oh, please, we wanted to do another problem. And I'm like, yes, I know, ha ha ha, you can't. So, there's nothing to be done here. We cannot do it. Can't be multiplied. So the question is, what does this mean about squaring matrices? So, what did I do? Oh, these are matching matrices. So if this is A, and this is also A, if we name that A squared doesn't always exist. That in fact, to square a matrix means they have to be a square matrix already. How's that? I know the patterns, the coincidences, all of this building of this beautiful world that is just so, it has references itself. It just blows your mind, right? I know Neo is very excited. So again, what do you have to remember from this? Well, try to remember as much as you can, but the big one is if you're asked to multiply two matrices, check their dimensions. Make sure that these inner numbers match, because this one doesn't. So, haha, no homework here. Presto changeo. Now we've got another problem. I know, I always have more problems. That's the thing about math teachers. No matter how many problems you solve for them, they've still got more problems. Yep. Okay, we're going to talk a little bit about properties of matrix multiplication. Now, in reality, again, this is just a little toesy dip into a giant branch of mathematics known as linear algebra. And you are going to study this more when you take the linear algebra class, if you take a linear algebra class. And so we're just going to introduce the concept. So we're going to say, let A, B, and C be matrices for which the following products are defined. What does that mean? Their dimensions are the right size. So let's make sure that we can do the multiplication. Then, if that is true, then if you multiply three matrices together, it doesn't matter which one comes first. So we've got an associative property of multiplication. Really cool, we have a distributive property of multiplication. So if you have an A on the outside and a B plus C on the inside, you can multiply A times B and A times C and then add them. And that works on both sides. So this is associative property. And these two are the distributive property. Of matrix multiplication. And so normally there are three properties. There's the associative property, there's the distributive property, and there's one other. And that is the commutative property. So the question is, will we multiply A times B and we multiply B times A? Do we get the same thing? And I would say as a note, why would we think they are? Well, if I multiply 2 times 3, that's 6. If I multiply 3 times 2, that's 6. They match, right? So the question is, if I multiply A times B, and then I multiply B times A, will they match? And that's what we're going to find out. So let's try. I've got two examples right here. Let us calculate A times B and B times A. So A times B is 5, 7, negative 3, 0 times 1, 2, 9, negative 1. So remember, we're going to go over and fall down the waterfall. Over the cliff, fall down the waterfall. Over the cliff, fall down. Over the cliff, fall down. Okay, so let's see. First row, 5, 7 times 1, 9. So 5 times 1 plus 7 times 9. First row times second column, 5 times 2 plus 7 times negative 1. Negative 3, 0 times 1, 9. Second row, first column, negative 3 times 1 plus 0 times 9. And then negative 3, 0 times 2, negative 1. Negative 3 times 2 plus 0 times negative 1. And as before, we could notice the 5, negative 3, 7, 0, 5, negative 3, 7, 0, 1, 1, 9, 9, 2, 2, negative 1, negative 1, right? So we got lots of patterns going on. Okay, so that's 5 plus 63, and then this is going to be 10 minus 7. Let's see, negative 3 plus 0, and negative 6 plus 0. So my whole final matrix, let me scooch myself up. pardon me, is 68, 3, -3, -6. Okay. Do we get the same thing if we switch the order? Now, it's natural to assume we would, but matrix multiplication is something special because we're distinguishing the rows from the columns. And so we're multiplying different numbers together. So take a look at this. Okay, so once again, first row, second column. So it's going to be 1 times 5 plus 2 times -3. And then first row times second column, 1 times 7 plus 2 times 0. So already you can see that different combinations are happening. See how the 5 and -3 were here? Now the 5 and oh, we haven't gotten to it yet. Sorry about that. So let me keep going. 9, -1 times 5, -3. I got ahead of myself. Sorry about that. You know when you get very excited about math. Yeah, totally. It happens. So, and then this across and down, 9 times 7 plus a -1 times 0. Okay, now we can talk about it. Here I've got the 5, -3, 5, -3. Here the 5, -3 and 5, -3 show up in different ways, right? The pattern has shifted. It's almost kind of turned itself sideways. So the question is, maybe they're in different places, but do I even get the same numbers? So let's look. I've got 5 minus 6, 7 plus 0, 45 plus 3, 2 negatives make a positive, and 63 plus 0. So this one's going to be -1, 7, and then this is 48 and 63. Now, do I get the same final matrix? And the answer is no. Are they close? Are they just reusing the numbers in different orders? No. Can I see when I look here the patterns? Yes, you can see the patterns, but we can see that when you use matrix multiplication, it mixes the numbers so much and in such different ways that if you change the order of multiplication, then you change the product. So now we have to be very, very careful with our multiplication. We can't just switch things around the way we're used to. So, woohoo, there's no commutative property. Which is a bummer, and it will be a bummer, and it sometimes gets frustrating, but we work around it. It's gonna be fine. So, but congratulations, because we finished this section. Woo! Nice work. Keep practicing matrix multiplication. Practice, practice, practice. The next section we're going to cover gets a little bit weird and a little bit cool. And we're going to teach you, well, I'm going to teach you, and Neo's going to be here to help me. We're going to teach you how to solve all those pesky problems that we did in Chapter 5 without ever having to use any of the Gaussian elimination tricks. I know. Now we tell you, right? Yep. So stay tuned. Come on back. Have a snack, get some hydration, get some sunshine or some rain, whatever it is you like. And know that you're awesome and amazing. Woohoo, and math on.